Hey guys, this is 11.4, adding and subtracting radical expressions. So before we were simplifying them, which just means get as many terms as you can, or as many parts of the term out from under the radical symbol as possible. This time we are going to combine them, and the next class is multiplying and dividing them. Okay, so as we are adding and subtracting radical expressions, you can only add and subtract like radicals. A like radical means that you have the same term under the radical sign, or you have the same radicand, okay? I would say this 2 square root x and this 9 square root x have like radicals. What we're saying is it's 2 times the square root of x plus 9 times the square root of x. Like radicals can be combined, okay? So what you do when you combine them is you just add how many, right? We are multiplying the square root of x times 2, and then we are combining it with the square root of x times 9. So we're just going to add the 2 and the 9, and what we get is 11 of them. All right. So that might seem pretty straightforward, pretty easy. So the challenge is going to be how to, if you have something like square root 2a, 4 square root 72a, negative 2 square root 32a, how do you combine them? Well, the first step is ensure that you have like radicals to combine. I also realized that I missed a part of it. So you need to have the same radicand. Which is what is under the radical. Okay, exact same radicand and same index. All right, so for example, 5 cubed root x and 10 square root x not like radicals because they do not have the same index, even though they have the same radicand. Okay, you need to have the same index and the same radicand. If you often must simplify radicals before you can determine if they're actually like radicals. So you want to get them into their simplest form before trying to add or subtract them. Okay. Normal restrictions for like terms still apply. So x square root 2 and 5 square root 2 are not like terms, right? Because you're not multiplying 2 times 9. You're adding them. 2 and 9 can be added to 11, but 5 and x can't be added. It wouldn't be 5x because that would be multiplication. Good. All right, let's practice. Just to clarify, kind of rushed that one. X square root 2 plus 5 square root 2 is already in its simplest form. All you can call it is x square root 2 plus 5 square root 2. You cannot take it any further. That's its simplest form because we're not multiplying, right? However, if you had x square root 2 and x square root 2, x plus x is just 2x square root 2. So those are like terms because you can add x plus x. The only reason these are not like terms is because you cannot add x and 5. All right, here we have 6 square root 2 plus 5 square root 2. Again, you have the same index of 2, and you have the same radicand of 2, so we can add them. 6 square root 2 plus 5 square root 2, you're just going to add the 6 and the 5. 6 plus 5 is 11, so it's just 11 square root 2s. I had 6 of them here. I had 5 of them here. I put the 6 of them and the 5 of them together, and I got 11 of them. Right? But up here I have X amount of them, which is a mystery amount. And I'm adding 5 of them. So I can't say it's 5x because that would be 5 times the mystery amount. 5 plus the mystery amount, square root 2. So you could write it as 5 plus x square root 2, but I would just leave it like that. Negative 4 square root of x minus 9, or sorry, negative 4 square root of 6 minus 9 square root of 6. Negative 4 minus 9, right? Square root of 6. Can you simplify it? Can you say, I mean, it says add or subtract. It doesn't say that we need to simplify, but you can always just make sure you can't simplify it. So for the squares, we can take our list of square roots, like 2 squared is 4, 3 squared is 9, right? So can I take 6 and divide it by 4? I cannot, right? 6 plus 4, or sorry, 4 plus 2 is 6, but 6 cannot be divided by 4. So it's already in its simplest form. Negative 4 minus 9 square root 6. Combining those, they're both negative, so we're just kind of adding them together, but we're keeping them negative, so it's negative 13 square root of 6. And again, you can't simplify the square root of 6 because you can't divide it by 4 or 9 or any of the bigger numbers. Negative 9 square root of 7 plus 2 square root of 7. I have negative 9 of them here, and I have 2 of them here. So it's just going to be negative 9 and 2 of them. Negative 9 and 2 is a negative 7 square root of 7. The square root of 7 is simplest form, right? Can't divide it by 4. I get another square root of 3 plus square root of 3. It's 1 square root of 3 and another square root of 3. 1 plus 1 is 2 square roots of 3, right? Because that's how we've been talking about it. We've been saying I have a negative 4 of them and I have negative 9 of them. Together, I have negative 13 of them. Negative 9 of them and positive 2 of them becomes negative 7 of them. 1 of them and 1 of them is 2 of them. Square root of 5 and square root of 3, not like radicals. Can you simplify square root of 5? No, it's a prime number, right? 5 cannot be divided by anything except 5 or 1. So you cannot combine them. This is its simplest form. 2 square root of x plus 9 square root of x is 11 square root of x. I have 2 of them and I have 9 of them. I combine them to get 11 of them. Number 8, 3 square root of x minus 7 square root of x. So I have 3 of them and negative 7 of them. 3 minus 7 of them. 3 minus 7 is negative 4 square root of x. Good. Now we have a cubed root. The cubed root of 3 and the cubed root of 3. So that's the same index, same radicand. So we can combine them. We cannot simplify the cubed root of 3. 14 plus 3 of them. 14 and 3 is 17. Cubed root 3. Here is cubed root x. I have 8 cubed root x and 15 cubed root x. 8 and 15, I think, is 23. Same index, same radicand, we can combine them. 3 cubed root 5y plus 6 cubed root 5y. 3 and 6 make 9. Those were the same radicand, same index. So we could combine them. We're flying through this, shoot. Also, hold on. All right, just wanted to make sure I wasn't missing a page. Guys, we're already on the last page. This is gonna be quick. When the instructions say simplify, it means the answer is left in radical form, just like the very end of the video, the last video, right? So leave it in radical form because the square root of 5, or even 8 square root 5, if I put it in my calculator, I can say it's 17.8885438.2, but it keeps going. It keeps going. So that's not the, it's not the actual exact answer. What we call it is a decimal approximation because the decimal keeps going and we don't want to write forever, right? So we just leave it in this form because then I'm only writing 2 numbers, but I'm representing a number that is very, very, very long if I were to write the decimal version of it, okay? So simplify, just leave it like this. Do not worry about the decimal unless it asks for decimal approximation, and then it tells you which one to stop at. Round it to the 3rd digit, round it to the 4th digit, round it to the 1st digit. Okay, do not use decimals in your answer unless they say decimal approximation or exact answer rounded to the nearest. Good. Okay, all variables represent positive numbers. It's just basically telling you it's not trying to trick you. So you just look at add and subtract. Add or subtract this. Don't enter them into the calculator all at once. Simplify them and then add them when it's very easy to add them and you can understand what your calculator is doing. Okay? So 3 squared of 3 plus 9 squared of 27. These are not like radicals, but we can say, can I take 27 and divide it by anything, right? Okay, so again, I'm going to just make a little list. Where? Up here. So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. Good, maybe 12. 144. Good. All right. So I have 9 square root 27. 27 may not be in its simplest form. What I want to do is take 27, look at my perfect squares because it's a square root. Look at my perfect squares and say, can I take 27? Can I divide it by 25? Can I divide it by 16? Can I divide it by 9? Or can I divide it by 4? 27 divided by 25, it's not going to work, right? 16, 9. Yes. Okay. So 27 divided by 9 is 3. This is just like the simplifying we were doing earlier. Okay. I'm going to bring down the 9 because it's 9 times the square root of 27. So I'm going to call this now 9 times the square root of, we said 27 is 9 times 3, right? 27 is 9 times 3. And why did we want 9? Because 9 is a perfect square of 3. So it's actually 9 times 3 times 3 times 3. And I'm going to take one of those 3's out. Right? Because this is a square root. So if I have a pair of terms multiplied by each other, I can remove them. That's the whole point. 9 times that 3 square root 3. Okay, so it was 9 times the square root of 27, which became 9 times the square root of 9 times 3, which became 9 times the square root of 3 times 3 times 3, which became 9 times 3 square root of 3. 9 times 3 is 27 square root of 3. We haven't done anything to that other term, so we're just going to bring it straight down. Now we have something that looks like that first page. 3 square root of 3 plus 27 square root of 3. I have 3 of them. I have 27 of them. I'm going to add them together and I'm going to get 31, 30, 7, 8, 9, 10. Yeah, 30. 30 square root of 3. It's in its simplest form because I cannot simplify a square root of 3. Good? All right. So take that same list. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. Down here, we know that the square root of 6 would just be, can I divide it by 4? No. 150, we can say, can I take 150 and divide it by, hold on, let me get it out. All right, I just wanted to have this list in the same view. So 6, we can't divide it by 4. It is in its simplest form. 150, we might want to start, it's not going to be 121, it's not going to be 100, right? 150 divided by 81. No. Good. 150. So I'm just checking to see if there's anything I can pull out. 150 divided by 64. No. 150 divided by, oh, maybe you should just go straight to 25 because you know that it will work, right? 49, 150 divided by 36. 150 divided by 25 is 6, okay? So I'm going to take that 7 times the square root of 150 and call it 7 times the square root of 25 times 6. Good. This stays the same. I don't even need to write it. I don't know why I started. Plus 7 square root of not 150, but 25 times 6. Good. Remember, we're doing that because 25 is 5 times 5, and then I can take it out. You're welcome to skip this step if you know that already. So that becomes a 5. And just like the 7 is being multiplied times the square root of 5 times 5 times 6, the 7 is being multiplied by the 5. Ah, that would be weird if that changed to a 7 magically. I wouldn't be able to explain that. Negative 5 squared is 6. Negative 5 squared is 6 plus 7. 5 times 5 under the radical becomes a 5 outside the radical. So now it's 7 times 5 square root of 6. 7 times 5 is 35. So now we have negative 5 square root of 6 plus 35 square root of 6. So now we're just taking negative 5 of them, combining them with 35 of them, and I think we just get 30 of them. Is that okay? Does that make sense? So you are simplifying these like we did in 11.1 and 11.3. You're simplifying them, and then you're combining them. Only if you have the exact same radicand and the exact same index. Good? Okay. Here we have the square root of 144, the square root of 32, the square root of 75, and the square root of 200. Now we have 4 terms. It might not be that all of them end up with the same square root, okay? It might be like that example problem where you can't combine it any further, all right? But we do know that 144 is a perfect square, so that just becomes 12. Square root of 144 just becomes 12. The square root of 32 is not on my list, but that's okay. So you want to take 32, and it's nice. I would start with the easiest number, to start with the small ones, right? 32, can't divide it by 36. Probably not going to be able to divide by 35, 20, 25. 32 divided by, let's start with 16. Oh, that's good. Why didn't I start with 25? Because it's too big, right? That number divided by 2, so this one is not going to be able to divide by anything because the smallest you can divide it by except 1 is 2 to get a whole number. All right, so 32 is 16 times 2. Move it down here. 16 times 2, and then 16 is 4 times 4, right? So that's actually 4 square root of 2. So the square root of 16 is 4. So the square root of 16 times 2 is 4 square root of 2. So now I have 12 plus 4 square root of 2. I still have 75, and I still have 200, and I'm definitely going to run out of space. All right, for 75, you might just want to go straight to 25, right? I know that 25 times 3 is 75. So the square root of 75 becomes the square root of 25 times 3, which is 5 times 5 times 3. That's a pair of 5, so it's now 5 square root 3. So the square root of 144 became 12. The square root of 32 became 4 square root of 2. And you can check that, by the way. Square root of 32 is 5.6568. And then 4 times the square root of 2 is that exact same number. So that's a good way to check that you've simplified it correctly. You get the exact same decimal in your calculator. 5 square root of 3 for the 75. Square root of 75. 5 square root of 3, exact same number. Good. And then we have 200. 200, ooh, 200 is a good one because it's 100 divided by 2. Sorry, the square root of 200 is the square root of 100 times 2, which is 10 times 10 times 2, which is 10 square root 2. We can check it. Square root of 200, 2, nope, 10 square root 2. Same number. Good. So this guy became 12. Square root of 32 became 4 square root of 2. Square root of 75 became 5 square root of 3. And then square root of 200 became 10 square root of 2. We've simplified it. Now we need to add or subtract if possible, okay? 12, and now that means like terms, okay? 12 does not have any like terms because 12 can only be combined with other whole numbers. So 12 just remains 12. 4 square root 2, 5 square root 3, 10 square root 2. That means 4 square root 2 and 10 square root 2 are like terms. So its final answer is 4 square root of 2 and 10 square root of 2 is 14 square root of 2. Here's my final answer. 12 plus 14 square root of 2 plus 5 square root of 3. Good? All right. Now we have negative 5 square root of 20 plus 10 square root of 125 minus 7 square root of 245. Kind of look at your list. Make sure you don't see any of those on your list. That'll make it easier. If you do not, I would start with the smallest number. Okay, so 20. Can I divide 20 by 16? No. Can I divide 20 by 9? No. Can I divide 20 by 4? I can, in fact, divide 20 by 4. So negative 5 square root 20 becomes negative 5 times the square root 20. I want to divide it by 4, right? Because 4 is a perfect square. 4 times 5, which becomes negative 5 times the square root 2 times 2 times 5, right? Which means the 2 comes out. And what we have is negative 5 times 2 times the square root of 5. The 20 became 4 times 5. 4 came out as 2. We're going to multiply those two together, and we have 5 under there. 5, obviously, you can't divide any further. And then negative 5 times positive 2 is a negative 10 square root 5. So negative 5 square root 20 is the same as negative 10 square root 5. Let's just make sure. Same number, okay? Next one is 10 square root 125. It's kind of easier if you go straight down, right? Okay, I'll go straight down now. 125. I can divide it by 100? No. 81. Have we already done 125? No, we did 150. All right, 125 divided by, you can go straight to 25 if you want. 81. Oops. 125 divided by 81. No. 64. No. 49, no, 36, 25. It's 5 times 25. 10 on the outside times, sorry, 5 times 25. We're taking the 25 out as 5 because that is 5 times 5 times 5. That is an index of 2, so we're looking for a pair of 2 5s to take out. So that's 10 times 5 square root 5. 10 times 5 is 50 square root 5. You can check it. 10 square root 125 gives you that answer. And then we said that that is the same as 50 square root 5. Good. So we have negative 10 square root 5 plus 50 square root 5. So that's good. Those can combine, right? And then we have negative 7 square root 245. And what you might want to do, since you know that you have you have a 5 under the radical, you might want to take 245. I don't think it's a perfect square. 15 squared is 225. 16 squared is 256. So it's not a perfect square, right? But if we take 245 and we divide it by 5, we get 49. Why is that helpful? Why did we want to divide it by 5? Because we want 5 left over so we can combine them all. All right, so we want a radical 5. So I just took that, and instead of going all the way down the list, I just divided it by what was left over from the other two. Yeah. Sorry, it's very distracting because it's going at a different refresh rate. So I'm just going to jump to, it's a negative 7, 245. And instead of going down the list, I just said I'm going to divide it by 5. So negative 7 becomes, or sorry, negative 7 remains the same. The square root of 245 becomes 5 times 49. And that is convenient because 49 is on the list. It's 7 times 7. So that's negative 7, 5 times 7 times 7. So those 7s come out. And the 5 stays in. And the 7 gets multiplied by the negative 7 out in front. So negative 7 times positive 7 is a negative 49 square root 5. Negative 7 square root 245. And then negative 49 square root 5 are the same, just to check, right? And then it's negative 49 square root of 5. Now we're just adding and subtracting. Negative 10 plus 50 minus 49. Negative 10 plus 50 minus 49. Negative 9. You could also just put it in your calculator. Negative, it won't work because it won't be in the right form, but negative 10 square root of 5 plus 50 square root of 5. Oops. Minus 49 square root of 5 gives me that number, right? And then negative 9 square root of 5 also gives me that number. And if you put all of that in your calculator, negative 5 square root 20 plus 10 square root 125 minus 7 square root 245 should give you that same number. They don't want the decimal. I mean, if they do, don't do all that. Put it in your calculator. All right. Square root of 2a plus 4 times the square root of 72a minus 2 square root 32a. Let's look at our list and see if, well, 2 is already in its simplest form, right? A is going to stay under the radical. 72a, 72 is not on here. 32 is not on here. 72, you just want to start dividing. 72 divided by 64. 72 divided by 49. 72 divided by 36 is 2. Sorry, that's kind of out of the frame. So 72 is going to become 36 times 2. So it was 4 square root 72a becomes 4 square root 36 times 2 times a, right? We're multiplying all of this. So it's 4 times 36 is 6 times 6 times 2 times a, right? We have a pair of 6s, so they can come out. So now it's 4 times 6 times 2 times a. 4 times 6 is 24. 24 square root 2a. So we went from 4 square root 72a to 24 square root 2a. And you can still do it with, just ignore the a. 4 square root of 72 should be the same as 24 square root 2. So 2a remains the same. 4 square root 72a becomes 24 square root 2a, and then negative 2 square root 32a. Negative 2 square root 32a. 32. Can we divide it by 25? No. Can we divide it by 16? We can. 32 divided by 16. So that's negative 2 times the square root of 16 times 2 times a. Why did we choose 16? Because 16 is 4 times 4. That can come out. So now it's negative 2 times 4 2a. Negative 2 times 4 is a negative 8. 2a. Minus 8 square root 2a. So now we have 1 square root of 2a plus 24 square roots of 2a minus 8 square roots of 2a. Just bring down the 2a. 1 plus 24 minus 8. 17. 1 plus 24 minus 8 is 17. And they all had 2a as their like radical. All right. Use a calculator to find the decimal approximation. Round to the nearest hundredth. All you have to do is the square root of 28. Make sure it's not under the radical anymore. Minus the square root of 343. Okay. If you don't make sure it's not under the radical, then you get square root of 28 minus the square root of 343. And you see how it's there, that radical is under the other radical. You're not going to get the same answer. So it's just make sure you can put 2 radicals into your calculator correctly. So rounding to the nearest hundredth, this is the tenths place, this is the hundredths place. We're looking at the number 28, and we're saying, is 28 closer to 20 or 30? It's closer to 30. So I'm going to say it's negative 13.23, because 28 is closer to 30 than to 20. Good. So that is negative 13.23. All right, guys, that is all for adding and subtracting radicals. Thank you for watching. Have a good day.